Hello and welcome to the session on Thales of Miletus. Abstract thought about the ultimate nature of the world and of human life began to appear in cultures all over the world during the 6th century BC, as an urge to move beyond superstition towards explanation. In this unit, we focus on its embodiment among the ancient Greeks, whose active and tumultuous social life provided ample opportunities for the expression of philosophical thinking. The first thinkers of antiquity are referred to as the pre-Socratics, even though some of these thinkers were in fact contemporaries of Socrates. The first podcast in the series look at the beginnings of Greek philosophy in the 6th century BC in the city of Miletus on the coast of Asia Minor. There, Thales and his successors, Anaximander and Anaximenes, developed theories referred to as material monism, deriving the entire visible cosmos from a single stuff or principle of water, the infinite and air. Thales of Miletus, 624 to 546 BC, was an early pre-Socratic philosopher, mathematician, and astronomer. He was one of the so-called 7 sages of Greece, and many regard him as the first philosopher in the Western tradition. He was the founder of the Milesian school of natural philosophy and the teacher of Anaximander. He was perhaps the first subscriber to materialist and naturalism in trying to define the substance or substances of which all material objects were composed, which he identified as water. His innovative search for a universality in the disciplines of mathematics, astronomy, and philosophy have earned him the label the first scientist. Thales was born in the Greek city of Miletus on the Ionian coast of modern-day Turkey in about 624 or 625 BC. The 3rd century AD historian Diogenes Lacertius reported that his parents were Examias and Cleobulina of the noble Milesian family of Thalidae and descended from Agenor or Cadmus of ancient Thebes, Greece. Details of his life are sketchy and often contradictory. Some reports suggest that he married and had a son, Cybisthus. Some anecdotes suggest that Thales was involved in business and politics and at one point bought up all the olive presses in Miletus after predicting a good harvest for a particular year. His involvement in local politics is also rather anecdotal in nature. But Thales apparently impressed both sides of the ongoing conflict between the Lydians, Medes, and Persians over the fate of the region of Ionia when he predicted an eclipse of the sun which brought fighting to a standstill. He was also reportedly involved in the negotiations which followed the hostilities and managed to obtain favorable terms for Miletus. Thales is said to have died of dehydration while watching a gymnastics contest in 546 BC at the age of 78. The writings of Thales. In retrospect, it is difficult to separate history from legend, but he is usually considered one of the 7 sages or 7 wise men of ancient Greece, a group of 7th and early 6th century BC philosophers, statesmen, and lawgivers who became renowned in the following centuries for their wisdom. The aphorism, "Know thyself," has been attributed to Thales. Much of what we know of Thales' philosophy has come down to us from Aristotle, and so may be somewhat distorted by Aristotle's own views. Some sources say that he left no writing. Others say that he wrote at least 2 works, on the solstice and on the equinox. Thales tried to define the substance or substances of which all material objects were composed, as do modern scientists even today. Hence, Thales is sometimes described as the first scientist. He searched for the physics of objects and caused them to behave in their characteristic way. He was one of the first Western philosophers who attempted to find naturalistic explanations of the world without reference to supernatural or mythological explanations, such as the Greek anthropomorphic gods and heroes. He explained earthquakes, for example, by hypothesizing that the earth floats on water and that earthquakes occur when the earth is rocked by waves. His most famous belief was his cosmological doctrine that water was the first principle. It is roughly equivalent to Anaximenes' later idea that everything in the world was composed of air. He claimed that water was the origin of all things, that from which all things emerge and to which they return, and moreover, that all things ultimately are water. He probably drew this conclusion from seeing moist substances turn into air, slime, and earth, and he clearly viewed the earth as solidifying from the water on which it floated and which surrounded it. While considering the effects of magnetism and static electricity, he concluded that the power to move other things without the mover itself changing was a characteristic of life, so that a magnet and amber must therefore be alive in some way, in that they have animation or the power to act. If so, he argued, there is no difference between the living and the dead. If all things were alive, they must also have souls or divinities. And the end result of this argument was an almost total removal of mind from substance, opening the door to an innovative, non-divine principle of action. Thales recognized a single transcendental God, monism, who has neither beginning nor end, but who expresses himself through other gods, polytheism. His idea of justice included both the letter of the law and the spirit of the law. For example, adultery and perjury about it in court are equally bad. He had some common sense moral advice that we should expect the same support from our children that we give to our parents, that we should not let talk influence us against those we have come to trust, and that we should not do ourselves that for which we blame others. He believed that a happy man was one who was healthy in body, resourceful in soul, and of a readily teachable nature. His political views were generally in favor of a benign tyranny rather than democracy. He believed that men were naturally better than women, and that Greeks were better than barbarians, non-Greeks. Thales was known for his theoretical and practical understanding and innovative use of geometry, especially triangles. He established what has become known as Thales' theorem, whereby if a triangle is drawn within a circle with the long side as a diameter of the circle, then the opposite angle will always be a right angle, as well as some other related properties derived from this. He was also an important innovator in astronomy, and he had an effective theory of the path of the sun from solstice to solstice, and supposedly correctly predicted a solar eclipse. Some sources have attributed him with the discovery of the seasons of the year and the 365-day year. His questioning approach to the understanding of heavenly phenomena arguably marked the real beginning of Greek astronomy. Thales' primary principle. Aristotle defined wisdom as knowledge of certain principles and causes. He commenced his investigation of the wisdom of the philosophers who preceded him. Thales is considered as the founder of natural philosophy. For Thales, this nature was a single material substance, water. Despite the more advanced terminology which Aristotle and Plato had created, Aristotle recorded the doctrines of Thales in terms which were available to Thales in the 6th century BC. Aristotle made a definite statement and presented it with confidence. It was only when Aristotle attempted to provide the reasons for the opinions that Thales held and for the theories that he proposed that he sometimes displayed caution. The problem of the nature of matter and its transformation into the myriad things of which the universe is made engaged the natural philosophers, commencing with Thales. For his hypothesis to be credible, it was essential that he could explain how all things could come into being from water and return ultimately to the originating material. It is inherent in Thales' hypothesis that water had the potentiality to change to the myriad things of which the universe is made: the botanical, physiological, meteorological, and geological status. In Timaeus 49 BC, Plato had Timaeus relate a cyclic process. The passage commences with that which we now call water and describes a theory which was possibly that of Thales. Thales would have recognized evaporation and have been familiar with traditional views such as the nutritive capacity of mist and ancient theories about spontaneous generation phenomena which he may have observed. Simple metallurgy had been practiced long before Thales presented his hypothesis. So Thales knew that heat could return metals into a liquid state. Water exhibits sensible changes more obviously than any of the other so-called elements and can readily be observed in the three stages of liquid, vapor, and ice. The understanding that water could generate into earth is basic to Thales' watery thesis. At Miletus, it could readily be observed that water had the capacity to thicken into earth. Miletus stood on the Gulf of Lade through which the Meander River emptied its waters. Within living memory, older Milesians had witnessed the island of Lade increasing in size within the Gulf, and the river banks encroaching into the river to such an extent that at Prime, across the Gulf from Miletus, the warehouses had to be rebuilt closer to the water's edge. The ruins of the once prosperous city port of Miletus are now 10 kilometers distant from the coast, and the island of Lade now forms part of the rich agricultural plain. There would have been opportunity to observe other areas where earth generated from water. For example, the deltas of the Hylice, the Ester, about which Hesiod wrote Theogony 341, now called the Danube, the Tigris, Euphrates, and almost certainly the Nile. This coming into being of land would have provided substantiation of Thales' doctrine. To Thales, water held the potentialities for the nourishment and generation of the entire cosmos. Aetius attributed to Thales the concept that even the very fire of the sun and the stars, and indeed the cosmos itself, is nourished by evaporation of the waters. It is not known how Thales explained his watery thesis, but Aristotle believed that the reasons he proposed were probably the persuasive factors in Thales' considerations. Thales gave no role to the Olympian gods. Belief in generation of earth from water was not proven to be wrong until AD 1769, following experiments of Anton Lavoisier, and spontaneous generation was not disproved until the 19th century as a result of the work of Louis Pasteur. Thales' ideas about the earth. Thales proposed answers to a number of questions about the earth. The question of its support, its shape, its size, and the cause of earthquakes, the dates of the solstice, the size of the sun and moon. In De Cassilo, Aristotle wrote, the opinion and the earth rests on water is the most ancient explanation which has come down to us, and is attributed to Thales of Miletus. He explained his theory by adding the analogy that the earth is at rest because it is of the nature of wood and similar substances which have the capacity to float on water, although not on air. In metaphysics, Aristotle stated, quite unequivocally, Thales declared that the earth rests on water. This concept does appear to be at odds with natural expectations, and Aristotle expressed his difficulty with Thales' theory. Thales anticipated problems with acceptance. because he explained that it floated because of a particular quality, a quality of buoyancy similar to that of wood. At the busy city port of Miletus, Thales had unlimited opportunity to observe the arrival and departure of ships with their heavier than water cargoes, and recognized an analogy to floating logs. Thales may have envisaged some quality common to ships and earth, a quality of floatiness or buoyancy. It seems that Thales' hypothesis was substantiated by sound observation and recent considerations. Indeed, Seneca reported that Thales had land supported by water and carried along like a boat. Aristotle's lines in Metaphysics indicate his understanding that Thales believed that because water was the permanent entity, the earth floats on water. Thales may have reasoned that as a modification of water, earth must be the lighter substance, and floating islands do exist. Herodotus was impressed when he saw Chimus, a floating island, about 38 kilometers northeast of Naucratis, the Egyptian trading concession which Thales probably visited. Seneca described floating islands in Lydia. There are many light pumice-like stones of which islands are composed, namely those which float in Lydia. Pliny describes several floating islands, the most relevant being the Reed Islands in Lydia, and Pliny described a circular floating island, its buoyancy and the way it moved. Thales could have visited the nearby Reed Islands. He might have considered such readily visible examples to be models of his theory, and he could well have claimed that the observation that certain islands had the capacity to float substantiated his hypothesis that water has the capacity to support earth. Milesian school. The Milesian school was a school of thought founded in the 6th century BC. The ideas associated with it are exemplified by three philosophers from the Ionian town of Miletus on the Aegean coast of Anatolia: Thales, Anaximander, and Anaximenes. Thales was the founder of this new school of philosophy. His two fellow Milesians, who also engaged in the new questioning approach to the understanding of the universe, were Anaximander, his disciple, and Anaximenes, who was the disciple of Anaximander. Anaximander was about 10 years younger than Thales, but survived him by only a year, dying in about 545 BC. Anaximenes was born in 585 BC and died in about 528 BC. Their lives all overlapped. Through their association, they comprised the Milesian school. They all worked on similar problems, the nature of matter and the nature of change, but they each proposed a different material as the primary principle, which indicates that there was no necessity to follow the master's teachings or attribute their discoveries to him. Each proposed a different support for the earth. Thales was held in high regard for his wisdom, being acclaimed as the most eminent of the wise men of ancient Greece, but he was not regarded as a god, as Pythagoras was. Anaximander and Anaximenes were free to pursue their own ideas and to express them in writing. This surely suggests that they engaged in critical discussion of the theories of each other. The Greeks are a sociable people, and their willingness to converse brought rewards in knowledge gained, as Plato remarked. Critical discussion implies more than familiarity with other views and more than mere disagreement with other theories. It is the adoption, or in this case, the development of a new style of discussion. It is a procedure which encourages questioning, debate, explanation, justification, and criticism. There was a unique relationship between the three Milesians, and it is highly probable that the critical method developed in the Milesian school under the leadership of Thales. Thales on mathematics. The practical skill of land measurement was invented in Egypt because of the necessity frequently to remeasure plots of land after destructive inundations. The phenomena is well described by Herodotus. Egypt was believed to be the source of much wisdom, and reports tell us that many Greeks, including Thales, Pythagoras, Solon, Herodotus, Plato, Democritus, and Euclid, visited that ancient land to see the wonders for themselves. The Egyptians had little to offer in the way of abstract thought. The surveyors were able to measure and to calculate, and they had outstanding practical skills. In Egypt, Thales would have observed the land surveyors, those who had a noted cord to make their measurements, and were known as rope stretchers. Egyptian mathematics had already reached its heights when the Rhind mathematical papyrus was written in about 1800 BC. More than 1,000 years later, Thales would have watched the surveyors as they went about their work in the same manner, measuring the land with the aid of a knotted rope which they stretched to measure lengths and to form angles. The development of geometry is preserved in a work of Proclus, a commentary on the first book of Euclid's Elements. Proclus provides a remarkable amount of intriguing information. Geometry originated in Egypt, where it developed out of necessity. It was adopted by Thales, who had visited Egypt, and was introduced into Greece by him. The commentary of Proclus indicates that he had access to the work of Euclid and also the history of geometry, which was written by Eudemus of Rhodes, a pupil of Aristotle, but which is no longer extant. His wording makes it clear that he was familiar with the views of those writers who had earlier written about the origin of geometry. He affirmed the earlier views that the rudiments of geometry developed in Egypt because of the need to redefine the boundaries, just as Herodotus stated. 5 Euclidean theorems have been explicitly attributed to Thales, and the testimony is that Thales successfully applied 2 theorems to the solution of practical problems. Thales did not formulate proofs in the formal sense. What Thales did was to put forward certain propositions which it seems he could have proven by induction. He observed the similar results of his calculations. He showed by repeated experiment that his propositions and theorems were correct, and if none of his calculations resulted in contrary outcomes, he probably felt justified in accepting his results as proof. Thalian proof was often really inductive demonstration. The process Thales used was the method of exhaustion. This seems to be the evidence from Proclus, who declared that Thales attacked some problems in a general way and others more empirically. Let us summarize what we have discussed so far. Thales is the first person about whom we know to propose explanations of natural phenomena which were materialistic rather than mythological or theological. His theories were new, bold, exciting, comprehensible, and possible of explanation. He did not speak in riddles as did Heraclitus, and had no need to invent an undefined non-substance as Anaximander did, because he gave no role to mythical beings. Thales' theories could be refuted, arguments could be put forward in attempts to discredit them. Thales' hypotheses were rational and scientific. Aristotle acknowledged Thales as the first philosopher and criticized his hypothesis in a scientific manner. The most outstanding aspects of Thales' heritage are the search for knowledge for its own sake, the development of the scientific method, the adoption of practical methods and their development into general principles, his curiosity and conjectural approach to the questions of natural phenomena. In the 6th century BC, Thales asked the question, what is the basic material of the cosmos? The answer is yet to be discovered. Now we can try to answer the questions given here. Why Thales labeled as the first scientist? Discuss the practical contribution Thales' philosophy. Explain the mathematical features of Thales' philosophy. What is the cosmological doctrine of Thales? Who were the Milesians and what they teach? What are the contributions of Thales to ancient Greek philosophy? Now, you may go through the reference books given here for further reading. Pre-Socratic Philosophy, Essays in Honor of Alexander Morilatus, written by D.W. Graham and V. Caston in 2002, published by Ashgate. The Oxford Handbook of Pre-Socratic Philosophy, written by D.W. Graham and P. Curd in 2008, published by Oxford University Press, Oxford. Cosmic Problems, written by D.J. Furley in 1989, published by Cambridge University Press, Cambridge. The Cambridge Companion to Early Greek Philosophy, written by A.A. Long in 1999, published by Cambridge University Press, Cambridge. The Pre-Socratics, written by A. Morilatus in 1974, published by Anchor, Garden City. A History of Greek Philosophy, written by W.K.C. Guthrie, 1962, published by Cambridge University Press, Cambridge. Hope that you have enjoyed this session. We can meet again with another topic. Thank you.